Hello my lovely students, welcome once again to Dr. Sourav sir's classes. We are going to continue with our videos on group theory. In the previous video we had spoken about what are the topics we are going to do in this part, and the first part we had done about some important points on the order of elements, and I told you to go ahead and study those points, or rather understand and study them so that you can relate to what is written. And today I'm going to give you a mathematical example on the order of elements and how it's happening. Okay, so please get ready with your notebook and your pen, because we are going to go on with this, right? Okay, so let's assume let's say G is a group. Let's say G is a group. G is a group of all bijections. You know what is a bijection? When it's 1 to 1 and on to, then yeah, when it is 1 to 1 and on to, then it's called a bijection. You know, right? You have studied this in small classes. Okay, so the function will be from R to R, making this example really small for you to understand. Bijection, the group is G of G group of all bijection from R to R. Okay, and there will be a binary operation, obviously, under binary operation. Some binary operation is there. Okay, binary operation composition of maps. Let's say composition of maps. All right. So let's start with a different color with the example of the mathematics part. Let's do with a different color. Let's say a little whitish would look nice. Okay, let's say if I give you the function f of x, very less place actually, is negative x. All right, if I give you the function as f of x is equal to negative x. Okay, of course for all x belonging to R. Okay, now let's find f of fx. What will be f of fx? That will be minus of minus x, that is plus x. You don't need to write, nobody writes a plus x, you just write an x, right? So what is happening? You see, you're getting an identity. Yeah, getting an identity here, right? Now look very carefully. If I take another function, let's say if I take another function up here somewhere, so let g of x is equal to what can I assume the function to be? Let's assume it to be 1 minus x. Okay, suppose if I assume the function to be 1 minus x. So now let's say if I do same thing what I have done here, like f of f, if I do say g of x, then what do we get here? We get 1 minus x, isn't it? Right. Then what are we getting the answer as? X, isn't it? We are again getting the identity. We are getting x. Now if you notice that the order, what is the order of f? What is the order of the function f? What is the order of f? Can you tell me? Since you see the element is equal to its it's coming here, see, it's coming identity, right? So you can say that this is what is happening. See, I'll make you understand. Okay, see, why is the order, what is the order, how will you find the order of f? Now you see, when you're doing f of f, you're getting the identity element, that means the inverse. So any element a is equal to its a inverse, right? That's why when you're using an x, when you're putting the x f of f, when you're putting minus x, you're getting the identity. That means the element is equal to its inverse. So if it's equal to its inverse, then a to the power 2 is equal to the identity. If a to the power 2 is equal to the identity, then order of f is going to come as 2. Alright, If order of f is 2, similarly order of g will also become 2, right? Because that is exactly what is happening. When I'm doing g of g, then I'm getting x. That means I'm getting back an identity element, right? Now if I do f of g, then what happens? Now let's find out what happens of f of g of x. Okay, so if I do f of g of x, that means I need to put f of x into g of x. Then that would give me 1 minus if I am to put that here, I have to put okay, what I have to put is, okay, so here we are going to have then f of 1 minus x, right? Because that's what g of x is, 1 minus x. So f of 1 minus x means, what is the function here? So negative 1 minus x will give us x minus 1, right? So that's what we are getting. Now look at this, x minus 1 is coming into a new function, right? So if I can write this as p of x, say, if I can write that as p of x, okay, it went on to the next, sorry about that. Okay, so if I write that one as p of x, just let's write that properly. Just hold on, okay, just a sec. So I write this as x minus 1 and I write this as, say, p of x. So if I got p of x there, okay, if I got that as p of x, then what I can do is, now I got a new function, right? Now if I do p of x to find out what happens with this function, okay, that means I get p of x minus 1, right? So I got to put x minus 1 here, so I got to put x minus 1 minus 1, that is giving me equal to x minus 2. Alright, so you're going to get x minus 2. Now if you continue this way, alright, if you continue this way, so let's rub out something on top here, okay, not the mathematics part, just little bit space is required. So if you look at this is x minus 2 is another function, okay. So if you do p of, again, p square of x, if you do like that, then what are you getting? You have to put again another x minus 2 here, so you're going to get x minus 2 over here, x minus in this one, in p of x, okay, in this part, x minus, in this part, x minus 2 minus 1, that is equal to x minus 3. Alright, and so on, it will continue because you are getting another function, so on, okay, not sun, okay. I'm very sorry, I wrote sun over here, let's say so on. Alright, the x minus 3 is nobody's son, okay, so it's so on and so on, okay. So it will carry on. So what can you say over here? The you see the order, it started with f of x, okay. From f of x we took another function g of x, and then we saw from g of x, when we are combining, doing a composition of g of x and f of x, we are coming out with a new function. What is the function? P of x, that is x minus 1. Now if we are doing p of x, we are not getting an identity, whereas we are getting a new function. Now again, if we do p of x, that is p of p square of x, we are getting to get another function. So that way we are continuing with let's say first we are getting x minus 2, then we are getting x minus 3, okay. Now again, if you do you put x minus 3 minus 1, you're going to get x minus 4. So are you getting any order of the element? No, because the power c, it's continuing, x, it will continue, right? It will continue on from here. So what is the order? What is the order of the element? What is the order of the element? Order of the element is not finite. You understood? Order of the element is not finite. Why? I will explain simply once again. I took a function on real numbers f of x. I did f of f and I found there is an identity element coming out. Then I took another function g of x, which is here. Okay, let's do with another color. G of x, that is here. Then when I took g of x from here and I did g of x, then again I got an identity element. Now what did I do? I combined both of them. Okay, let's take another color. What color can I use? Color man. Okay, then again I did the composition of f of x, and then not f of x, f of g of x, and I found I am coming out with a new function, so I let it be p of x. Now when I do it p of x, I came out with another function. Then again what must I do? I must continue with that p of p square of x. Then again I came out with another function. So if I continue with this function, then what I am getting? I am getting a polynomial that does not that's powered is continuing x. So if you keep multiplying x, you're going to end up right until infinity. So the order of the element is what? Is not finite. Okay, is going on right until infinity. So students, I hope you have understood this example for from order of the element. Okay, I know it's a little bit confusing, but I would expect you to go through more examples or go through more videos of us so that you understand better. Okay, and you can implement these in your exam. So that's it for today, students. You keep taking as much help as possible, because all the help that you will be needing will be provided here at Sourav sir's classes. Thank you very much for watching.